Alright, so continuing on this chapter, we have the worksheet Exponential Puzzlers. So this is a pretty fun worksheet. So the first problem is you win a radio show contest and have 1 minute to choose between receiving $10,000 or you can get the sum of the following payouts for 30 days, right? So day 1 is we get 1 cent, day 2 you get 2 cents, day 3 you get 4 cents, day 4 you get 8 cents, so continue doubling, and then find out day 30, right? So in order to find day 5, right, so day 5 would equal day 4 times 2, right? So 8 cents times 2 is 16 cents, right? So that's part A, 16 cents. So now it asks how much money do you get on day 30, right? So one way to build an exponential equation, so you should have maybe learned about geometric sequences like in high school before, and how these look is you'd have like a to the n equals, and then you have your first term times your multiplier raised to the n minus 1, right? So one way to build this equation is if we use p for the number of the amount of money you would have on that day, you would have equals, and then a1, so how much we have on day 1 is 1 cent, right? And then my multiplier is times 2 to the, we could use d minus 1, right, where d equals the days, and p equals the money, right, the amount of money. Right? So we could build that equation, right? So my equation is p equals 2 to the d minus 1, right? You could also get this equation through investigation, right? So like 8, this is 2 times 2 times 2, right? 4 is 2 times 2. 1 is just 2. Day 5 was 2 times 2 times 2 times 2, right? To get 16 cents. So notice if you look at the day number, there's one less factor of 2, right? So that's another way you could get this equation, right? Just through investigation, you could see that pattern. All right, so for day 30, p would equal 2 to the 29th power, right? We'd have 30 minus 1 to get 29. So if you do that, you should get, it's like 536, 870, 912, and this is in cents, right? If we convert this into dollars, right, so what I did is did 2 to the 29th power, right, so you can enter on your calculator and you get that value, and then if you want to convert that into dollars, we can divide by 100, right? So if you wanted this in terms of dollars, you would have what would be, what, 5,368,709 and 12 cents, right? So that's the amount in dollars. This is the amount in cents, right? So now it says how much do you get in total, right? So this is where a spreadsheet can be really helpful, right? How much should we get in total? So let me open up an Excel spreadsheet so we can fill in days and I'll just put money, right, the amount of money that we're getting. So I can put 1 here, and then I can use a formula in Excel to add 1 each time, and we want to do this for 30 days. Oh, 1 more. Right? I'm actually going to insert another column in here, right? And my money, let's have this be in terms of dollars. Or let's do cents, right? So let me wrap the text here. And then I'm going to do money and cents again. And then I'm going to come over here and do money in dollars. Wrap text for these. And at the very bottom, I want to do total, right? So, and I'll make that black, add some borders, right? Make it look nice. Right, so that's what I have so far. So then, with this money and cents, I'm going to type recursive up here. I'll explain this in a moment. And here, we'll do closed formula. So, when you're reading in the text, you should have noticed that there are two different ways to come up with a formula. We can have a recursive formula, or a closed formula. So, a recursive formula is where your previous value so your value depends on what your previous value was, right? So let me grab one note back, right? Let me just write here. So in other words, how I was writing this above here, right? So day 5 equals day 4 times 2, right? So in order to get day 5, it's dependent upon day 4, right? We have to know what that is, right? So that's what we call recursive formula. So in other words, to get a recursive formula in Excel, right, I would type in 1 cent here, right? And then below it, I would do equals, and then take the one above it times 2, right? And then if I fill that down now, it's built on a recursive formula, right? It's taking the one before it and multiply it by 2, right? We have a cell reference, right, to the previous amount. Right. So then, if you want a closed formula is using this guy, right? That is my closed formula. So what I could do is I could come here and do equals, and then do 2 to the, and then I need to put this in parentheses. Oops, I know it's yelling at me. So we need to take the day, which is over here, minus 1, right? So if I hit enter, and then I fill this down, these should match along the way, which they do, right? These are matching. Oops, we didn't need those filled in. There. Got that fixed. Well, I can go ahead and build this formula, right? So this we would want to use the sum formula, highlight all of these, hit enter, and then I can just pull this over, right? And Excel will add the right things together, right? So then to convert this in money, I need to do equals, and I could reference either one of these, right? And then I need to divide by 100 to put it in terms of money, and I'm going to go ahead and format it as money, and then we can fill that down. Remember, these mean there's not enough room, so we need to make some more room. And now everything is in terms of dollars, right? So let me make this terms of dollars. We're good to go, right? So we use this spreadsheet to help us do this. So ask, what's the total, right? How much would you get total? Well, this would be my total, right? That in the blue, we would get $10,737,418.23, right? So one nice thing about this example is you can see how quickly just 1 penny doubling can grow, right? So, you know, obviously the $10 million is way better than getting 10,000, right? All right. So let me go back to the worksheet. So we got that. So then the next couple of problems have us finding averages again, right? So for number 2, we're asked what's the average rate of return for a mutual fund, right? But these would involve factors again, right? So we would have some growth decay factors. So with number 2, we're still going to use a geometric mean, right? With number 3, though, we have some densities, right? So we have some densities here. So here we're going to need to use harmonic mean. And then number 4 is similar to a problem we did on the last worksheet, right? So we'll save that for when we get to it, right? So remember, to find this, what I'm trying to solve for is, I know that if I have 1 plus, so we have 1, 2, 3 rates, right? So 1 plus R1 times 1 plus R2 times 1 plus R3, and if this is multiplied by my my original amount, my initial amount, this should be equal to P naught times 1 plus R raised to the third power, right? Because it's 3 years, right? 1, 2, 3 rates. So what I'm trying to solve for is R, right? So R1 is this amount, R2 is this amount, right? And R3 is this amount. And notice again how we've talked about, I can divide both sides by P naught and those go away, right? So I don't even need those. So the equation I need to solve is 1 plus R cubed equals, and then I would have 1 plus 0.072 times 1 minus 0.043, and then times 1 minus 0.091, right? It's getting cut off a little bit, right? Let me fix that. 091, right? So to solve this, I'm going to have to take the cubed root of both sides, right? Cubed root. So now I'm left with just 1 plus R on this side. So then I'm going to have to subtract 1, right? So R is going to be equal to the cubed root of all of these multiplied together, right? Minus 1, right? So R equals, so I can use my calculator, right, to do this. So let me turn it on. So I need to do the cubed root of, so we have 1 plus 0.072 times 1 minus 0.043 times 1 minus 0.091. I need to get outside of the root and minus 1. Right, so then this is in decimal form, so if I multiply by 100, I can put it in percent form. Whoops, I only did times 10, right? So that's fine. I can just multiply by 10 again, right? Same as multiplying by 100. So R, we get negative 2.3%, right? So that's my average rate of return, right? So remember, whenever we have things we're multiplying together like this, in order to find the average, we need to use geometric average, right? And harmonic average is used for densities, right? So using the equation for the harmonic average, right? So if you remember on page 15 in chapter 6, right? Which I brought up in the last video, the harmonic mean looked like this: n over, and then you have 1 over a to the a1 plus 1 over a2 plus ... plus 1 over a n. Right, this should be an n there. Let me fix that. Right. So here I just have two things, right? So my n is 2, so this will be 2 on the top. And then I would have 1 over 11,340 plus 1 over 19,300, right, would be the harmonic mean of these two, right? But one thing to note is that, like, x to the negative 2 is equal to 1 over x, or excuse me, I'm pulling in the wrong rule here, what I was thinking of, right? Okay, so if I have, like, the number, I don't know, 5 to the negative first, this is equal to 1/5, right? So if I have 11,340 to the negative first, this is equal to 1 over 11,340. 11,340, right? So in general, if I have x to the negative first, this is 1 over x, right? So I was going to approach this more general using negative exponents, but I'm really only concerned about the negative first exponent right now, right? So this always happens. So you don't have to use this, but this is a nice shortcut way to enter it in the calculator if you'd want, right? So to do this, I could do 2 divided by, and I need to put my put this in parentheses. So I would have 11,340 to the negative first, right? So I had a button here on my calculator to do the negative first power. And then we'd have plus, and then 19,300 to the negative first, and then close parenthesis. Right? And putting that denominator in parentheses is important because of order of operations, right? And we've looked at that in previous chapter. So I can hit enter, and there's the answer that I get, right? Excuse me. So the answer here, I'll write in a different color, right, would be 14,286 kilograms per meter cubed, right? That's my density. So that's my density of the resulting alloy. So I had to average those two densities because I was mixing them together, and we're looking at what's the new density, right? So that's what it would be rounded, right? All right, so I need to do some erasing here to make room to work on number 4. Let me erase this so I can read. All right, so number 4 says Apple Incorporated had a net profit of $57 million in 2003 and a net profit of $14,013 million, right? So that would be $14 billion, right? In 2010. So it says, wow, what was the average change of Apple's net profit over the 7-year period, right? So part A in dollars per year, that's like finding in the previous worksheet, right? So if you recall back to number 7 in the previous one, where we had a town growing 12,456 people to 32,980 in 5 years, right? So that was on page 72 in the worksheets. Part A says, what is the average total change? So this part A is the same type of thing, right? It's just worded differently. So we're still finding average total change, right? So the average total change here would be, so we would take 14,013 minus 57 all over 7 years, right? So if I do this, you should get 1,993.7, and this would be dollars, and this would be in million, right? So million per year, right? So that's the, in dollars per year, that's the answer, right? 1,993.7 million per year. And then as percent change per year, right, we have to use this guy, right? So 1 plus r equals, and I've done it by hand a few times, right? Spelling it all out, right? But one of the shortcut way that was presented in the previous worksheet, so on page 71, you had this equation: 1 plus r equals to the nth power, the new divided by the original, right? So if you wanted, you could have this formula on like your note card and use it on the exam, right? And you could use that to find this value, right? So what we'd have is 1 plus r equals, so the nth root, we would be the 7th root this time, right? 7 years. And the new amount was the 14,013. The original amount, or the old amount, was 57. And then obviously I'd have to subtract 1 from both sides to get r by itself, right? So r would equal, and then you could figure this out, right? So we need to do the 7th root of 1413 divided by 57. Then get out of there, minus 1. And we get this. So remember, this is a decimal. So if I multiply by 100, I'll get it in percent form. So my average percent change per year is 119.5% roughly, right? Per year. Per year, right? So that's one way to do this. If you don't like using this shortcut formula, right, and you want to stick to how we did it before, you could use this formula pretty easily. Oops, we used t before, I believe, right, for this exponent. So we could fill this in also, right? So p here would be 14,013. P naught would be 57, and then you'd have 1 plus r raised to the 7th power, right? And just solve for r. Solve for r, and you end up doing the same calculations. You end up doing this, and you'll obviously get this as your answer still, right? Either way, it's perfectly fine. Right? All right, so this has a lot of reading to do, so I already have read this and understand the problem. So if I were you, I would probably pause the video here and read over this paragraph, right? But essentially what happens is at 11 p.m. we have a bacteria who keeps eating, and then every minute it doubles, right? So 1 bacteria becomes 2 bacteria, and then 2 bacteria become 4 bacteria, and they keep doubling every minute, right? And then at midnight the bottle is completely full, right? So question 1 says the catastrophe occurred because the bottle became completely full at 12 midnight. When was the bottle half full, right? So if you want to visualize this, here's my bottle. Here's where it's 100% full, right? 100% full. And this occurred at 12 midnight, right? So if every minute it doubles, then the minute before midnight, so 11:59, the bottle would have been 50% full, right? Or half full. So the time here would be 11:59 p.m., right? So question 2 says you are a mathematically sophisticated bacterium, and at 11:56 you recognize the impending disaster. You immediately jump on your soapbox and warn that unless your fellow bacteria slow their growth dramatically, the end is just 4 minutes away. Will anyone believe you, right? So let's think about this a little bit, right? So I know that at 12 we're 100% full, right? At 11:59 we're half full. Let me put the bottom of my bottle here, right? So then at 11:58 we're 25% full, right? Or if you want to represent this as fractions, right, you could do that also, right? So this would be 1, 1/2, 1/4. So then at 11:57 we would have been 1/8 full, right? So then at 11:56 we would have been 1/16 full, right? So that's what we're looking at, 11:56 p.m., right? So I would say no here. No one's going to believe you, right? No. No one will believe us because we are only 1/16 full, right? So it's hard to believe that 56 minutes went by and we only filled up 1/16 of the bottle. So it's hard to believe that we would fill up 15/16 in just 4 minutes away, right? So I would say no one's gonna necessarily believe you, right? That sounds crazy. We've been in here for 56 minutes and we're only 1/16 of the way full, right? I have all this room and I don't believe it's gonna happen in just 4 minutes, right? So in question 3, so again, you might want to pause and read that. But basically what's happening is at 11:59 when we're half full, we're going to send everybody away to some other bottles, right? So we find 4 other bottles. So here's bottle 1, bottle 2, bottle 3, bottle 4. So we had a bottle up here, it's all the way full, all the nutrients are gone. So we're like, hey, we found 4 other bottles, like 4 other planets, if you will, to go to. So 1/4 goes here, 1/4 goes here, 1/4 here, and another 1/4 here, right? So we start out at midnight, all of these a quarter full, right? So at midnight, we're 1/4 of the way full. So we're asking how much more time do the additional bottles buy for the civilization, right? So if we're all the bottles are 1/4 full, right? This is a 1/4, this is a 1/4, they're all a 1/4, right? All of them will match, right? We put even number in each bottle. Then at 12:01, this will double and be half full, right? And then at 12:02, this will double and it'll be all the way full. So at most we would only get 2 more minutes before all 4 are full, right? So this only buys us 2 minutes. Then 4 bottles are full, right? And when the bacteria runs out of nutrients to eat on, they're gonna die, right? So we're kind of exploring this as, oh, we need to go somewhere else to live, and that's why the bacteria keep wanting to find new bottles to live in, right? So question 4 talks about, so it says, because the 4 extra bottles bought so little time, the bacteria keep searching out more and more bottles. So we're wondering, is there any hope for additional discoveries that will allow the colony to continue its rapid growth? So we're told a volume for each bacterium, which is 10 to the -21st cubic meters, and we're told the surface area of the Earth. And we're wondering at 1 a.m. how deep are the bacteria if they are evenly spread over the surface of the Earth, right? So if we take all those bacteria, spread them all over the Earth evenly, right? So assuming that we can, right? Because I know a lot of the Earth is water, right? So assuming that we could, how deep would they be with that, right? So how to figure this out is we needed an equation to figure out, well, how many bacteria am I going to have after 120 minutes, right? So after some investigation, you should come up the equation to be this, right? Where P equals the number of bacteria and X equals the number of minutes after midnight, right? So my multiplier is 2 here, right? So I'm thinking this form, y equals a times b to the x, right? This is my initial, and this is my multiplier, which is 2. So my initial value is 1 bacteria, so I would just have 1 times 2 to the x, which is just 2 to the x, right? So my equation is P equals 2 to the x, right? I can get that equation pretty easily from that, right? So after 2 minutes, right, I would have 4 bacteria, right? Which is what we had before. So at 1 a.m., x is equal to 120, right? So the number of bacteria I have would be 2 to the 120th power, right? So if I wanted to find the volume, right, of all this bacteria, we would take 2 to the 120th and multiply it times 10 to the -21st cubic meters, right, to find that total volume. So this comes out to be 1.33 times 10 to the 15th meters, right, if we put that in scientific notation, right? So if we take 2 to the 120th times 10 to the -21st, we get that value, right? So 1.33 times 10 to the 15th, right? So that E in my calculator is scientific notation, right? So that's how that is transcribed, right? So that's the volume that I have total, right? So to find height, right, if I take surface area and multiply it by height, I can get volume, right? So in other words, my height is equal to my volume divided by my surface area, right? So if I fill these in, I could find how tall they would be, right? So I would have 1.33 times 10 to the 15th meters cubed. This should be cubed. And then divide this by the surface area of the Earth, which is 510 million. So that'd be 510 times 10 to the 12th, right? So a million is 10 to the 12th. This would be meters squared. And then if I divide these, so you should be looking at dimensional analysis, right? Meter cubed divided by meter squared is just meters, right? Which is good because height is only measured in 1 unit. If we if you do the simplification here, this should come out to be 2.6, right? So if I take 1.33 times, whoops, also I need to put parenthesis here, right? So 1.33 times 10 to the 15th, whoops, gotta put the right arrow to get out of the exponent. So 1.33 times 10 to the negative 15th, if I divide that by 510 times 10 to the 12th, so push the right arrow, close my parenthesis, it equals, we get that, right? 2.6. So 2.6 meters would be the final answer there. All right. So, you know, if going too fast in the video, don't forget you can pause, rewind, and whatnot. Make sure you capture all the things I'm doing, right? All right, thanks.